Okay, there's two parts to today's video. Both of them leading to how to calculate the area of a square. The second one, please do it practically. It's about actually creating sectors to derive a formula for the area of a circle. We're going to go through a quick one now, which leads to it. This is more intuitive than an actual proof. The other one is the basis of a proof. So task one is we're doing an intuition on it. What we say is we are looking at a circle, and the circle is based upon a shape which has this square in the top right hand corner, and it covers the circle. The simplest shape we can think of, and that's a square with radius, a square with the side the same size as the radius. So the area of this square is the radius squared, and if you want to play with numbers to follow through what's happening, I'll put the numbers in green on the right. So the radius, when the radius is 1, the area of this square is 1 unit. So the first part of our reasoning is I can put 4 of those squares and they will just cover the circle. So the area of the circle is related to 4 areas of the square, and 4 r squared, or the area of the circle has something to do with the number 4. That's what we can say. Now, how is it related? Well, the squares are bigger. There's a bit on the outside of each of them, all the way around. So that means the 4 squares has more area than the circle. So the circle is less than 4 times the square, less than 4r squared, or if the radius is 1, less than 4 units. Now I can do a copy of that circle and do something similar. Let's go again. Let's draw a circle, preferably the same size. There we go. And we're going to draw another square in it. And this square we're going to do in a funny way. This square starts with the same 2 arms to start with. But now I'm going to connect the points that make the connection to the circle. So we're going to draw a square inside the circle along those sides. And what's inside the circle is that triangle there. So what's the area of the triangle? Now the area of that triangle is a half the area of the square in the first one. Half area of the square. So if you're working in numbers, the area of the triangle is 1/2. I can go through how many of them are there. So the area of the circle is 4 of these. 1, 2, 3, 4. 4 halves the area of the square. 4 times a half. That's for the triangle. But if we have a look on the outside, there's a bit extra then. So the circle is bigger than the area of that square. So the circle is bigger than this number. It's bigger than, well, that should be a times 4 times a half. So let's simplify as much as possible and substitute in. So the area of the circle is bigger than 4 times a half is 2. Area of my square is r squared. If you're working in numbers, area of the circle is bigger than 2. So we've got a conclusion we can draw. We've got the same circle, analysed it in 2 ways, and the area of the circle, we know, is bigger than So I'm taking the big side is A, small side is 2r squared. 2r squared is smaller than the area of the circle, and on the big side, so A is small, and the 4r squared is big. So that means we've got somewhere between 2r squared and 4r squared as being the area of the circle. Now, from the following video, part of the video where you practically do it, what number do we know is somewhere between 2 and 4 and got something to do with circles, and it's going to be related to that. So let the other video come in, or the other part of the video come in, where you practically create it, and we'll come back and create the formula in the end. Okay, what we're going to do today is I'm going to suggest you do this a couple of times, but use fairly large circles. At the end of the measurement lesson, I asked you to trace some fairly large circles if you can. These little bottle cap type ones, they're too small to really work with. It's better if you're using most of the page. And what we're going to do is we're going to take 2 pieces of paper and we're going to make a copy or cut out that circle. I'm not going to work with this original one because I want to be able to put that down and make some sort of poster. So I've got the diameter of the circumference. We're going to work out and demonstrate how you can calculate the area of this as well. And I'd like to be able to put the two together. I haven't got any coloured paper at home, so I understand if you haven't, but we would normally have done this in lesson with coloured paper. So what we need is a pair of scissors, and I would suggest, if you can, tape your 2 pieces of paper together so that they stay exactly the same. Then cut out the circle that we're going to work with. So I'll just do this and then I'll pause it and show you it, having cut out this tape. Stop the paper moving between each other. As you can see, I made quick notes on the back of this when I was doing the measurements before, and I'm going to reuse the paper and do the same thing on the other side. This just stops the 2 pieces getting out of step with each other when I'm cutting out, because I want to make 2 circles that are as identical as possible. Now when I start cutting this out, sorry, that's my coffee machine, I'm going to try and smooth the circle a little bit as I go through, but I'm not going to go too far with it because it's actually the shapes we can create that I'm more interested in. So I'm going to start over here at the top and I cut the circle out as close to the edge as I can, and I'm going to do that carefully, so I'm going to pause the video for a moment. So I come to the end. I've gone a little bit inside sometimes and outside the other, but what we're going to do is we're actually going to be talking about using the circumference, the distance around the outside, and the radius. So before we go any further, the radius is the distance from the centre of the circle to the outside. Now I'm not sure how to find it at the moment, so the easy way to do, and we're going to do this a few times anyway, so it's worth doing now, is if you fold the circle in half so that your circle matches up and fold through the middle. Do the same thing going the other way, and we're going to use this anyway. So I'm just going to fold that to the middle. As you can see, my circle cutting wasn't exactly best, it's probably the tracing wasn't particularly good. So when I fold it out, I now know the centre is in the middle there. Now I don't think any of you are going to be surprised when I measure that, and it should be about half the distance of my diameter. And I'll put that down, try and turn it around. I know you're not going to be able to see these, but I do want you to see that I am being as honest as possible. And I've got a distance of 8.6 centimetres as being my radius. That's by measurement. I don't think anybody would be surprised with these two are half. I'm going to write 8.6 centimetres as being my radius. That's what I measured. But we now have a little note that I can add to this. Radius is 1/2 the diameter. Okay, so I'm making notes on my circles as I go around. I'm using this to keep my notes. Right, this is where we're going to go. I'm going to use the same one and do it a few times, and I'll show you what the principle is of how we can calculate the area. So I'm going to cut these quarters up, be as accurate as I can. Put those two there because they are supposed to be the same. Lined up straight through the middle, and I've got 4 sectors. And the question is, what can I do with those that will help me create the area of the shape? Well, the rearrangement that you will get shown is you fit them together to make this sort of snaky pattern. And the reason you get told to do that is we've got a lumpy bit down the bottom here and then a gap at the top. And it looks like they could be about the same distance. So we're going to go again. We're going to take all the sectors and we're going to keep cutting them up. And I'm going to fold this. So I've got my sectors. So that's not a particularly good one to try using. Quarters, not enough. So I'm going to fold it in half to give me some sectors. Try and get everything tucked in neatly if I can. And again, I'm going to cut them in. Now we're going to be making 1/8. So cut straight through the middle. Hopefully you can be careful with your scissors. Hope I don't have to tell anybody, not one with the scissors, don't play with them. So now when I join them up, what we get is what is actually a parallelogram. Now you can keep going, but if you look at them, what you find is this small section at the bottom here is getting smaller and smaller, and so is that extra bit at the top. And they seem to be getting closer and closer to being exactly the same height. Same thing happened actually with when we did the quarters, but we keep going. Now I'm going to stop it after this next one. Now, some people say calculate the area of the parallelogram. I can simplify the problem for you, so you don't have to remember how to calculate area of a parallelogram. Let's split the last sector in half and do the same thing you do when you're calculating. So I'm going to cut this last section off the end, cut it through. And this will be a good reminder of how the area of a parallelogram can be calculated. So I'll take that parallelogram. If I cut this extra section off where it's cut perpendicularly, this is now almost a right angle to a curve. I'll put it on that end. What I now have is a rectangle. And the rectangle, if I keep chopping these up smaller and smaller and smaller, it has the length here, which is 1, 2, 3, 4/8 of my circumference. And when we were doing the calculation of the circle, we found that the circumference is pi times the diameter, and 4/8 is a half. So this length here is half of pi times the diameter. And as we found earlier when I did this cut, half of the diameter is a radius. So that's pi times the radius. That's the length along that line. The other length on the rectangle is that distance there, which is the radius. So the area of this rectangle is the long side, pi r, times r, the short side, which gives me overall the area as pi r squared. Now have a quick look at the notes, because I know this is upside down and it's back to front, and even if I hold it up like that, it reads it back to front. I haven't sorted out those videos. Okay, but that's the physical parts. There's some notes that you will see on screen for the video there. So the area of this, we've now just shown, is area is pi, area of this circle, that is pi, the number we calculated in the first lesson, which is about 3.14, times the radius, 8.6, squared. If you grab your calculator, it's over here, do shift and pi times 8.6 squared, and I get 232.4. So this is 232.4. Length times a length is centimetre times a centimetre, or centimetre squared. So that circle now, I've got all that information in. With the areas for these, if you're doing the demonstrations, do put all of this together, put it all onto one sheet of paper. So I can put my circle over here. I can show my rectangle, and I can show the rectangle comes from. I'll put that like that. I'm putting my rectangle, trying to show that the little lumpy bits above actually cancel out with the gaps underneath. So put the sections in, glue it down, do it as a demonstration for yourself. It would be nice if we could get some photos of them for people. So if you can get some photos showing what this is. Normally we'd stick it on the wall, but we haven't got a common wall to do. So I could actually put that, and so this is pi r. This radius here is an r. So we've got pi times r, pi r squared. It's the area of a circle. So in conclusion, what we can make is, so hopefully from the last one, the last bit of video that you've just done, let's put the picture in just so you can remind yourself. We've got the area of a circle can be broken down into a series of sectors. The more sectors, the more accurate it becomes, and these little bits become cancel out a lot more. We've got a radius, and we've got half the circumference. So that's pi times the diameter divided by 2. Diameter divided by 2 is radius. So the length across the top here is pi, and the pi r, and the length down the side is r. I hope that's, don't know why the pause is in there. So let's just add that to this diagram. On here, we've got a length r. The length across the top there was pi d divided by 2, because they've got the sectors at the top. If I show you where the circumference is that one, in that one, then we come to that one, and these go together to make the outside of the circle, all these red bits. Okay. So the length along the top is pi d over 2, which can also be written as pi r, because d over 2 is r. So the area of my rectangle, let's put it back into normal yellow. So the area of this rectangle, or the area of the circle, is approximately the area of this rectangle. And the area of that rectangle was approximately pi times the radius times the radius. Now, in mathematics, there's an idea of something called taking the limits. So the limit is an infinite number of sectors. All these little regions above and below cancel out. So this bit of brown here cancels out with the extra little tiny bit of white at the top there. And they're actually the same, and they cancel out. So we get the area of the circle is exactly equal to pi times the radius squared. And from the start of the video we did this section, we know area of the circle is somewhere between 2r squared and 4r squared. Well, that number between 2 and 4 is pi. Pi being 3.14159 and continues forever. So we've got the area of the circle formula. So now we can actually calculate some areas. So I'm going to do the areas of the two circles we did before. I'm going to do them the other way up for a simple reason to do with, there's a little trick for the first one that you need to remember. The exercise today will be for the shapes you can do this cutting up for. I'd like you to do 3 or 4 of them where you can tell me what the circumference is, the radius, the diameter, and calculate the areas, including doing that cutting up for 3 or 4 different circles that you made on Tuesday. So let's just go through and calculate the areas of these two circles. Like I said, I'm going to skip over this one first. These are the same ones we did with the circumference. We're going to come to the second one first. What information have I been given? I've been given r equals 4. I want to work out the area of the circle. So A of a circle is pi r squared. So I put my values in. Pi times 4 squared. Notice meters, and I need a calculator. It's just loading. There we go. Turn it on. Pi button's down here, so I press Shift, Pi, and I want 4 times 4 r squared. I'll show you something with a calculator in a moment as well. Be careful about. I use the squaring button. It just means I don't type mistakes when I've got longer numbers. So I use the square number button, and this gives me an area of 50.26, which I would probably round to 1 decimal place. 3 significant figures, and the units were in meters squared. Now, I said I want to show you something to be careful of. Some people try to be lazy when they're typing in their numbers, and if you do pi, and because we write the formula pi r squared like that, some people try to put 4 squared, and a lot of calculators will give you an error. The pi needs a multiplication sign after it to separate it from the number. You can normally, let's cancel it and go this way, I can normally put the number first and then put pi afterwards. It's following the rules of algebra. Okay? Rules of algebra, unknowns come after the coefficient. So if you know what the number is, it's being a little bit funny about the way it's treating pi. So that's that one. Shift. Turn it off. Oh, actually, I need to turn it on because we need to do the next calculation because I skipped one. So we're going to go back to this one. And the question is, what have I been given here? Oh, this time I've been given a diameter. So the diameter of my circle is 7 centimeters. Well, my formula for a circle is in terms of radius. So I change the diameters to radii. So the radius is a half the diameter, 3.5 centimeters. Hopefully you didn't need a calculator for that one. I bring my calculator back in. I'll write out my calculation. Pi times 3.5 squared. writing pi like that should be acceptable. People don't need to know that you know 3.14. And I don't expect many questions to come up and use pi as 22/7 anymore either. So we do pi times 3.5, and this is why I like using the squared button, is that 3.5, there's no risk of me making an error with it again. If I made the mistake, I made it the first time. And this is an area of 38.5, 38.48. I want it to be one significant figure, one decimal place, and the units. We're now working in centimetres. The centimetres are on the radius is squared, so my units is squared. And that's how you can calculate the areas. So for today's lesson, you've got the questions. The questions are, for some of the shapes you measured on Tuesday, what's the area? So I calculate the area. Measured on Tuesday. Okay, that's your task. Good luck with it. Try to make a nice display from them. If you can get a screenshot, we'll see if we can get some up on the website showing people are still working and what we're doing.